as we have mentioned in the previous lecture, the main goal of Six Sigma is to eliminate defects, decrease their number, and in this way improve the quality of the process. Therefore, let's try to define what we actually mean by defects, and obviously I'll try to show you some examples. Now, by defect, we mean any unacceptable deviation from the norm that the company sets for a specific process outcome. In most cases, the defect is process output, in other words, product or a service that does not meet customer requirements and expectation for quality. Bear in mind that for every process, the customer will be a different person. And also, you should not forget that we can have internal customers as well as external ones. So whenever you have a process, you have to define first of all who is the customer, then what a good output is and what a bad output, in other words, defect is. And to show you how this can be done in practice, we're gonna look at 3 examples. We'll try to define defects for doctor visits, train transport, and production of clothes. Now, in the case of the doctor visit, we assume, as it was in the previous example, that the threshold is 20 minutes. So if the doctor visit is above 20 minutes, we have unfortunately a defect. In other words, unhappy customer. So if we measure all the visits, we will most likely notice that some of them will be above 20 minutes and some of them will be below. So the things which are above 20 minutes will be our defects, and we've got them here in red. And as you can see, it's 20% of all customers. Then 80% we actually manage to do below 20 minutes. Therefore, these are the high quality or no defects customers which are satisfied with our service. In a similar way, we can treat the train transport. Here, let's assume that being on time, arriving on time, will define whether it's a defect or not. So if the train is on time, then we assume that this is not a defect. And then if it's late, obviously we consider that a defect. So here, after we have measured 100 trains on a specific day, you will discover that 40% of them were punctual, so they were on time. So this is high quality, no defect production, and then 60% were late. Obviously, in certain situation, we can make the definition less stringent, and we can assume that, for example, up to 1 minute, it's okay, whereas above 1 minute is a defect. If this was the case, the proportion between the defects and non-defects would be obviously different than what we show here. We would have obviously less defects. Now, the last example, it's the production of clothes, so something from the fashion industry. And here, the small squares are not customers, but rather models that we have created for the season. Now, if the model meets the quality requirements, then we assume that this is a good product. And then if it does not meet, obviously this would be a defect. And let's say we got something like that. So 67% of the products met quality requirements, so there are no defects, and 33% are defects. We could obviously define the high and low quality, so non-defects and defects, in a bit different way. So for example, for the fashion industry, instead of quality, we could have reaching certain threshold of sales per model. So if a specific model is selling fewer than assumed in the threshold units, then we would consider this a bad product. In other words, we didn't design it properly, therefore the customers were not buying that. So have a look at that, and remember that for every process, you have to define what a defect is to know what you should actually minimize in the Six Sigma.